right, this is your graphing linear systems warm-up before your test. Let's go over this together. You had some time to work on it. This says that Ava and Aiden are both running a trail that is 3 miles long. Ava started running before Aiden started. Both runners are running at a constant rate. The graph below shows the distances y in miles. Now, something I want you to add to this sheet that is not there is along the y-axis, please write distance in miles. So the y-axis is distance in miles, and the x-axis is your time in minutes. So if I keep reading there, distance y in miles that both Ava and Aiden were from the beginning of the trail as a function of time in minutes x since Ava started running. Now something I notice up here, this is 3 miles long, so the trail is 3 miles long. I notice down here along the x-axis, that's time in minutes. Along the y-axis is distance in miles, and notice that probably right here is 1 mile. So you have to make sure you go by the intervals. I'm going to take my information here. It says Ava is a solid line, so I'm going to write Ava's name here so I know I'm watching Ava from there. And then I'm watching Aiden along this bottom line. I notice that the point of intersection is right here. We call that the POI. And I notice that that is the ordered pair 10, 1. So that's really 10 minutes, 1 mile. So let's go down to some of these questions and see what you came up with. The first question says, what is the constant rate? And notice it's underlined in miles per hour that each person is running. Well, constant rate is your slope. So we need to find both persons' slope. So I'm going to start with Ava. Ava starts at the ordered pair 0, 0. And the point of intersection was 10, 1. You can use the counting method or you can use the formula. I'm going to use the formula. 0 minus 1, 0 minus 10. That gives me negative 1, negative 10, which is really positive 1 over 10. Now I want to put words with that so I can interpret what it means. So remember the numerator is the y-axis, and the y-axis is distance in miles. So that's 1 mile. And then on the denominator we have a 10, and that is minutes. However, it asks for the constant rate in miles per hour. So I have to take this 1 mile every 10 minutes and convert it to hours. We need to know how many minutes are in an hour. Hopefully you all know that there are 60 minutes in an hour. So I'm going to put 60 in the denominator. I'm going to ask myself, because I want to create myself a ratio that is equal, 10 in the denominator minutes. If I multiply that by 6, I get 60 minutes. So to make it equivalent fraction, I multiply the numerator and I get 6 miles in 60 minutes. And 60 minutes is really an hour. That means Ava is running at 6 miles per hour. So make sure that makes sense to you. We found the slope. We wrote slope as 1 mile over 10 minutes. However, it wants miles per hour. So we converted the 10 minutes to 60 minutes. 10 times 6 is 60. So 1 mile times 6 is 6 miles, which gives us Ava is going 6 miles per hour. I also need Aiden. So I'm going to go over here. Let me see if I can change the color. Hold on a second. There. I don't know if I can change the color. I'll try. Aiden. Nope, I can't change the color. Aiden has the ordered pair 4, 0 and 10, 1. So I'm going to follow suit. I'm going to do the slope. When I do the slope, I'm going to subtract 0 minus 1, 4 minus 10. In the numerator, I get negative 1. In the denominator, I get a negative 6. That is really 1 over 6. And following suit, just like the last one, the 1 is the y-axis, which is miles. Sorry. And the denominator is 6 minutes. However, remember, they do not want it in miles per minute. They want it in miles per hour. So I'm going to convert my 1 mile over 6 minutes to 60 minutes. So I have to think, what do I multiply 6 by to get to 60 minutes? 6 times 10 gives me 60 minutes. So I'm going to multiply my numerator times 10, and I get 10 miles over 60 minutes. That means that Aiden runs 10 miles per hour. So make sure you get all that information from your graph, because that's how you find their rates in miles per hour. Now let's go down to the next question. It says, how many minutes after Ava started running did Aiden begin his run? I really wish I could change my color here. I can't. Let me put this down time. I can't. Alright, so Ava started at 0 minutes. So Aiden started 4 minutes after Ava. So I'm going to say here, Aiden started to run 4 minutes after Ava. So make sure you can look at your graph and interpret what it means if they ask you questions. What does the 0.10(1) mean? We'll kind of touch base on that up above. The 10 means after 10 minutes, Ava has run 1 mile and Aiden has run 1 mile. But remember, Aiden started after Ava. And then the last question says, how many minutes before Ava will Aiden finish running the trail? So you have to know the trail, how long it was. At the beginning it said the trail was 3 miles long. You have to use that information. So I'm going to go over here to the left. Ava, she goes 1 mile in 10 minutes. So I'm going to use that idea of a fraction that's equivalent again. If I want to know 3 miles, this time I put it on the numerator. I'm trying to find out the denominator. So use my numerator. 1 mile times 3 gives me 3 miles. So 10 minutes times 3 would give me 30 minutes. So Ava runs 3 miles in 30 minutes. Aiden runs 1 mile in 6 minutes. So I need to know 3 miles for Aiden. Again, I find the idea of equivalent fractions and multiply by 3. I take 6 times 3, that gives me 18 minutes. And then, how many minutes before Ava will Aiden finish? I'm just going to subtract the 2 times. 30 minutes minus 18 minutes. So my final answer is 12 minutes. And that is how your warm-up is solved for today.